Assalamualaikum warahmatullahi wabarakatuh. Now let's continue on the PN junction diode. So what you're going to learn for this topic is, let's recall what is N-type and what is P-type. So for your N-type, you're going to dope with silicon with group 5. Example of group 5, that is phosphorus or arsenide. So what you are going to have inside your N-type is the majority carrier is electron, and minority carrier is hole. Okay, and for your p-type, you're going to dope with group 3. So example, boron or aluminium. So when you dope with group 3, the majority carrier will be hole, minority carrier will be electron. So why we have what we call here donor ion? Same with here, we have what we call acceptor ion. So for your N-type, the valence electron for your group 5 is 5, right? So it's trying to donate. So remember last time, donor impurities, so it's trying to donate some electron. So when you're trying to donate, you have what we call charge. So this charge, what we call donor ion. The donor ion is positively charged. So remember, so for your donor ion, the charge is positive and it cannot move, it's static. So this is what we call static ion. Majority carrier and minority carrier is the one that can move. Why we need it to be moved? Because we want the current, right? So it can be moved. For electron, it can move, and minority carrier also can move. But what will be in the static ion? So why we have static ion positive here? Because it's trying to donate. So this ion is static and cannot be moved. For your p-type, because you dope with group 3, right? So instead it's trying to donate, it's trying to accept here. Accept electron. So when trying to accept, you are going to get minus charge here. So this is what we call acceptor ion. And this acceptor ion is again static ion. It cannot be moved. What will be moved is only the majority and the minority carrier. Okay, now, so what will happen when we just now is only P and only N, right? So now we will see what will happen when we start to join P and N together side by side. So when there is no bias applied, so it means when we're talking about P-type, we have acceptor. So this is what we call Na. When we have N-type, we call this one donor. So that's why we have N and D. Okay. So when you join together, so the level of the concentration will be different here. So how you going to calculate the concentration is Ni squared divided by Nd. So this is from the previous lecture. Okay. So now what we're going to see here is the what will happen when we start to build the PN junction. So there are 3 keywords here. The first one here is diffusion, second is recombination, and the third one is depletion. So let's see the first one, diffusion. So in your p-type, you have majority carrier here is electron. So let's say this is p-type. So what will happen when we start to put p and n side by side? In your n-type, the minority carrier here is just now. So this is in p-type, this will be the majority carrier here is hole. Okay. In your n-type, what is the minority carrier? Minority carrier is also hole. So let's say here you have a lot of hole. Here is only one hole. So what will happen when we have this side by side? So you're going to see that the hole here will start to move to your n-type. Why? Because this is high concentration and here is low concentration. So the hole from your p-type will move to the n-type. Now what will happen to the electron now? So let's say here is The majority carrier for your n-type here is electron. So let's say this is electron. So the purple here is electron. You have a lot of electron at your n-type, but you only have a minority carrier. You only have one electron at your p-type. So your electrons start to move from n to p. So how we can denote this one? To the left is electron diffusion or hole diffusion. So towards the left is what we call electron diffusion. Okay, but towards the right is hole diffusion. So what is the concept of diffusion here? Is from high concentration to the low concentration. So this is number 1. The diffusion of electron and hole in both ways. Okay, so let's see what will happen next. So let's say I draw again. So this is p-type, this is n-type. So inside your p-type, you have majority carrier of electron. Inside your p-type, your majority carrier is hole. So let's say this is hole. And here is only one hole. So this electron, this hole will move to the right. So it will be a lot at the boundary. Okay. How about the electron diffusion? So let's see here. Okay, so this is, let's say, electron. So it will start to move the p junction. So you start to move at the junction. So now what will happen at this junction? Electron and hole will start to, what we call here number 2, recombination. So electron and hole will start to combine and replenish. Okay, so the keyword here, electron and hole will start to combine. Combine at where? At the junction here, and vanish. So it will be gone. When it start to combine, it will be gone. So okay, so when the diffusion happens, so it start to meet the electron and hole at the junction. So when the electron and hole meet at the junction, it will start to, what we call, recombine and vanish. So means there will be no more electron and hole at the junction. So if I withdraw this one, so instead of like this, so it will become, there will be no carrier inside. So means they combine and vanish, they combine and vanish. So inside here what we call depletion region. So it will be number 3, what we call depletion region. So how depletion happens? So first diffusion will happen. Hole will be go to the right, electron will go to the left. So once it start, number 2, you start to combine here and then vanish. So there will be depleted, means depleted of carrier. So what does mean by carrier here? Carrier is what we call free electron or free hole. Okay. So where is your depletion? Depletion is in this region. But is it really empty? So remember previously we mentioned that inside your p-type and n-type there is what we call static ion. The charge that cannot be moved, right? So in your p-type you will have negative charge. In your n-type you will have positive charge. So this charge what we call static ions. Either it is donor ion or acceptor ion. So while we're having this charge, it will create what we call electric field. So there will be electric field from positive charge to the negative charge. Okay, so let's see the slide. So in the slide, it shows in different way n-type and p-type. So what will happen when you combine p and n together? So the one that is showing here is electron, and here is hole. So free electron we start to move to the p-type, free hole we start to move to the n-type. Why? Because of the different concentration. Okay, so when p and n start to move, what will happen at the middle? So in the middle here, this is the middle part. So it will start to combine and vanish. So means at your junction here, at this area here, there will be no more free electron and free hole. So it will be both electron and hole will be vanish. So then the third keyword is depletion. So where is the depletion region? Is this area. There will be no more carrier inside because it's already vanished. But what left behind is the fixed hole, that is the static ions. So we have fixed hole and fixed electron. Where this comes from? Because of the static ion just now, the donor ion and the acceptor ion. So once you have the charge here, plus and minus, it will create electric field. So electric field will move from positive to negative. So positive and negative ion are formed by gaining or losing electron. So positively charged by losing electron. So what does that mean? So let's say it's your n-type phosphorus. You are trying to donate, right? When trying to donate, so you become positively charged. For your p-type, let's say boron, you're trying to accept, you become negatively charged. So p-type negatively charged, n-type positively charged. So this is what it means. Okay, so let's imagine. Now there is electric field at this opposite side, right? So let's say here is your p and n type, right? And then when there is an electric field, you want this hole to move to your n type. But your electric field is at opposite sides. It's like a force to not allow this electron to jump to the n type. So this is what we call built-in voltage. Our aim inside your p and n type, let's say this p and n, you want the hole here to move to the n type, you want the electron here to move easily to the p type. But when this happens, there is some depletion here and it will create a force opposite from what you want. So means you want the hole to move to the right, but there is a force opposite that not allow the hole to move. So this is what we call built-in voltage. So in order to pass that electric field, so we need extra energy, right? So what is the extra energy there is what we call built-in voltage. So electron and hole need extra energy to pass the barrier. So why there is extra energy? Because there will be electric field that force the hole not to flow. It will block the hole from flow, will block the electron from flow to the hole p-n junction. So the term here is we call built-in voltage. Built-in voltage.